Alright, I'm going to show you where these square waves are coming from, or how they're generated. Let's go quick algebra. Slope is rise over run. This is just an example of a straight line. There's your run, there's your rise. Divide the two, you get a slope. So now, in order to get these square waves like this, you have to add all the sine waves together and divide it by the same number. So look here. So you take sine x plus sine 3x divided by 3 plus sine 5x divided by 5, 7, 7, 9. You just keep going. You just keep adding these odd numbers up. I graphed it on my computer, and it looks something like this. So this is only plus and minus 1 volt. So if you want to get the 5 volts, which is most of the things we use, you just put a 5 in front of this whole equation, and if you look here, it's plus and minus 5 volts. So eventually, if you keep adding these odd numbers, these things get straighter and straighter. It'll never get completely straight. I put it on my graphic calculator here, up to 9x. So you can see, it'll eventually get almost straight, but it'll never get straight. So let me show you something here. See these edges here, they're sharp corners, which doesn't exist. It gets really small curve, but as you can see, the run is on the bottom. So this run here, left to right, is basically 0, and you cannot divide by 0. And what that means is there's nothing instantaneous at all. It might go super fast, but you can't go from 0 to 5 volts in 0 seconds. You could do it in microseconds or in milliseconds, but you can't go from 0. So of course, if we draw it as square waves, but in reality it's a tiny curve on each of these edges where the voltages rise and drop very quickly. So that's where the square waves are generated from. Of course, if you want 12 volts, you put a 12 in front of this, or whatever voltage you need, you just put it in front of this equation, and that's where they're coming from. So